we've got something great next because it is, obviously, Quantum for Finance. We're going to talk about quantum accelerated AI. And so to do that, we have the CEO of Pascal, Georges-Olivier Raymond, with the head of Global Market Division Quantitative Research at Crédit Agricole CIB, Christophe Michel, moderated by the Quantum Lead and Startup Program Leader at OVH Cloud, the wonderful Fanny Bouton. Please welcome all three of them to the stage with a huge round of applause.
Hi. Thank you, Ethan, for the presentation. I enjoy to animate this panel with Georges-Olivier Raymond, CEO of the wonderful startup Pascal, about a quantum computer, and Christophe Michel, head of Global Marketing Division Quantitative Research and head of GMD, Pricing Service GUI. Long title. Welcome, both of you. Thank you to be here with you. We talk about how quantum can accelerate AI today and what is quantum computing also. Christopher, can you just tell us about what you do about quantum at Crédit Agricole?
Yes. First of all, we started to, let's say, explore this fascinating area in 2020. And the idea was to know what about quantum? How can it help what we do, knowing that in general, in capital market in particular, but in all the bank, as I think most of you know, we are a lot of we are hugely consuming calculation. So the question was, okay, and what about quantum computing? So we first investigate in what can it be, what could be the use cases, etc. And we convinced, and I would like to thank our management for that, we convinced our management to start some proof of concept. And to do that, by our own, it was not possible. So we looked for partners to go in this field, and we found Pascal, Georges company, and also Multiverse. And with these two companies, we have started two box.
Okay. Georges, can you just tell us what is Pascal, what you do at Pascal?
Yes, we are a French company. We are based south of Paris, and we are building quantum computers. And we are leveraging a new technology, what we call a neutral atom. And to make it short, we are leveraging the fact that we are using pristine qubit, I mean atoms, built by nature. And to make it short, they are operating at room temperature, and they are just perfect by nature. So we can scale the number of qubits quite easily, at least faster than the competition. We are not only building the hardware, we are building the software on top, like developing quantum algorithms that are helpful to develop the applications thanks to them. And when I created the company with my co-founders 4 years ago, we had this vision in mind that the current technology was enough to address real-world use cases. At that time, it was just a vision, and now, thanks to the partnership with Crédit Agricole and Multiverse, we proved we were right. And it's only the beginning. And to make the connection with AI, because this is the title of this event, I would like to say that for me, and not only for me, but I think Kay Fully also stated that quantum computing will be the true enabler of AI. I mean, to implement AI, you need a huge computational power at the lowest energy cost than today. And you can have that thanks to quantum.
Okay. Can you tell us, I'm a bit interested, how you find together, how you start your story? This is Crédit Agricole who search, or it's Pascal start the discussion? How it starts this story?
Well, so we had this initiative within Crédit Agricole, and we wanted to have a use case, let's say, to practice and to do some effective experience. So that's one hand. On the other hand, we met, I think it was Canton Nation, and part of so it's It's a company, yeah, it's a fund, and part of the portfolio of Contonation, there was Multiverse Computing and Pascal. And in this discussion, we found that it was probably interesting to look into the possibility to be partners in some experience. Then the question was to know what will we do together, and we started the discussion this way.
And what are the use cases that you use? Today we are at IA for Finance, and can we do really AI use case with a quantum computer? Georges?
Yes, definitely. I will let Crédit Agricole explain how they related the use cases to AI. But definitely, yes. I mean, all the use cases and quantum algorithms that we are developing today are related to AI. We can do machine learning, graph machine learnings, optimization, and in some sense, it can be AI.
Yes, perhaps to continue. In fact, we selected two use cases. One was about pricing. The question was pricing of derivative products. So in capital markets, it's very, very time-consuming and very important. So it was done, we started that with quantum-inspired algorithm. So it was not pure quantum, but it's inspired, and there are some leaks. And the second one, it was about the experience of fallen angels. What is it? If you have an investment grade counterparty, the question is how to forecast the downgrading of this counterparty. We have some algorithm, so for that. The question was to know, can we do the same with quantum? And it was interesting for us because then we could benchmark quantum versus not quantum, and could we do better? So that was the question. And to select these two use cases, in fact, it was the fruit of the interaction with Pascal and Multiverse to know, okay, does it make sense? Do we have a chance to achieve? Yes, and actually, in fact, it was more than an achievement. It was very interesting in several fields.
Georges?
Yes, and just to highlight the fact that it was just the beginning. You know, we worked together and with Multiverse on this use case, but I hope we will have a new one soon. I mean, at least we done our job on our side, but you know, we are also leveraging the technology, the hardware, and our algorithm for other domains such as biochemistry, drug discovery, and very recently we just implemented a new one, and we will unveil it soon, I hope.
Sorry, yes,
No,
to say something about, in fact, when you start, the idea is that there is something that a quantum computer can do and which is very difficult to solve in the standard world, which is to optimize in a discrete world. So to have kind of a discrete problem that you want to optimize, and there are many discrete problems that are in general, let's say, approximated by something continuous. In the continuous time, you can do something, but in the discrete, okay, you have then to map on that, and there are many heuristics, and it's painful, time-consuming, etc. What we saw with the experience with Pascal was that, in fact, this is an area where there is a clear advantage of the quantum computing. So each time you have a discrete optimization problem, then really it makes sense to think of quantum for that, because it will it will be better than the standard approach in general. That's one case. In fact, there are many other kind of algorithms that are eligible to quantum, and that's the reason why I think it's the beginning of the path.
Georges, can we say this is now the quantum revolution?
It's the beginning of a journey. I prefer to frame it this way. I mean, as you can see, the work we've done with Crédit Agricole, actually, it's the way for you as end users to really have your hands dirty on quantum. And this is really important because we are not that far away from the revolution. We know what it takes, I mean, at least at Pascal, to reach this point, thanks to the work we've done together. And we are like 2 or 3 years away from that. So it's already tomorrow. So if you want to be ready in 2 or 3 years, you'd better start now. Start your quantum journey, learn how you can use a quantum computer, what it is good for, and develop the use cases. Because otherwise, I mean, you will just be behind your competitors, and there is a high risk, I see that, to have a shortage both of talents and hardware. Because believe me, these computers are very hard to build, and there will not be so many around reaching the so-called quantum advantage.
Christophe, what are the next use case that you want to try on quantum computing? Do you have ideas already?
So, beyond what we are currently doing, which is in fact leveraging of what we know which works. So I say binary optimization, so it's a bit not financial, but in fact it can be the optimization of repartition of trade in a portfolio in order to optimize a given, what we currently do is to optimize our scarce resources, the funding, the capital, etc. So that's something which is very important for us. But I think a next step, which is probably, which needs a bit more qubits than what is currently available, but which would be very interesting for us. The next step is in the deep learning area. So, of course, we are talking about generative AI, but in AI in general, there are a lot of use cases using neural networks. There are a kind of complexity in the learning phase of that, and definitely we think, in fact, thanks to the discussion we had also with your guys, Georges, we think that there are really promising use case of the quantum in this area where the neural network could be partly replaced by the quantum computer in a very efficient way.
And George, what are your next clients, your next projects in the finance area? Do you have?
They are in the room, I hope. No, seriously, now we have the hardware, we have a full software stack. We also have tools to help you starting your journey. We have an e-learning platform, so you can train yourself, your team, and really start your journey. And we are open for partnership, because I mean, if you want to be at the same level than Crédit Agricole, you have to have your hand dirty, and we provide everything that is needed to do that. And on top, you will also have access to our support. We have a team of experts to do that. So please come to me after the panel. We also have a booth to meet the team and discuss the use cases we could work on together.
Okay.
No, just one word to add. I think it's worth talking about all the side effect, the positive side effect. When you let's say invest in this area, the quantum computing, then of course it is the first side effect. It's a real pleasure because it's absolutely amazing. That's very, very interesting. So that's a side effect which is not very financial, but personally it was perfect. This side effect, in fact, spreads to all the students and the good profiles and the innovation, let's say, mood in the industry. And definitely, it brings a lot of good talent, at least interested, perhaps not directly to work on this area, but to be happy to know more about that. And also, because we are always benchmarking, comparing quantum computing versus standard methods, also there are side effects which are on the standard world, which is okay. In fact, I could have done better another way than I used to do, because I just asked myself another time the question with a benchmark which is simulating. So just to say that it's a side effect also, but really it's a valuable one.
Thank you, Christophe. Last question, Georges, we have 1 minute left. You can tell us about the possibility that it's more green to use quantum computers, and it's not only money, but to have advantage on that.
Yes, it's a very important point, because what we are calling the quantum advantage, meaning that a quantum computer can beat classical technology, we are thinking about performances, about accuracy, about computing time. But it could also be exactly the same thing than before, but just using less energy, 10 times less energy. That's the potential of quantum today. And on top of that, you can also use a quantum computer to help us saving energy. We are working with EDF, for instance, the French electricity utility, to optimize the distribution of electricity to electrical cars. So now we can act on both sides of the equation. And as of now, since it's still like a potential, we have a processor which is very low energy intensive, good. But now we need to make this promise real. And that's the reason why we started this initiative with the so-called the Blaise Pascal Hackathon that we launched a couple weeks ago. And the idea is exactly to measure the impact, the positive impact, of course, of quantum computing on our carbon footprint, on the entire life cycle, starting with the construction of the processor, the way you are programming the processor, because if you are programming it in a bad way, you're just making rubbish, and then you are wasting energy, and of course the impact of the use case by itself. So I think it's a very pressing problem, and if you want to tackle it today, just apply for this hackathon.
Thank you very much, Christophe and Georges, and see you in the other room to discuss more. And thank you all of you to be here with us.
We actually are waiting on the minister to show up, and since we have two wonderful guests here to chat with, if you have another question or two, feel free. If you don't have another question, that's okay, but instead of you listening to more bad jokes, you can listen to them, maybe talk. So if you have another question or two, we're still waiting on the minister. So.
Yeah, it's a nice. Thank you for the joke.
You're welcome.
Okay. About maybe price or cost, how much is it to add the hour to use a quantum computer?
Sorry, I didn't get the question.
The price of the hour to how to connect and to use your quantum computer. Actually, because you have how many machines you have, and where are they?
Okay, it's a short question, but the answer can be rather long. So
I think it's the goal.
Sorry, it's a tricky question.
That's the goal of a question, so very good one. So you have two ways to access the technology. The first one being using all the tools we developed, so basically the software stack, and as a back end there is an emulator. And this, I mean, it comes for free. Just connect to our GitHub page. You can download the libraries, which is called Pulsar. So you will code a quantum computer using a Python environment. So, and of course, there's an emulator as a backend, so it's not a real quantum computer. You can also have access to I forgot the name, Pulsar Studio, which is the same version of Pulsar, but using it with an API, so with a no-code environment, if you want to. So it's graphics, very easy to use, and again, it is free. If you want to go to the next level, then we have our onboarding program that we call Quantum Discovery. It's an e-learning platform. So there is a training part, and you will learn how the quantum computer is working, what it is good for. And at the next step, you have access to the first quantum algorithm, and you will have the ability to tweak the parameters of the algorithm. So you will see the effect of them, and so you will get the sense of how it works. And in the package, you also have access to a real quantum computer at the end, because now we have one which is up and running that we will launch in the coming weeks.
It's really interesting because we can start to learn and code about quantum computing on a laptop, in fact, actually.
Yeah. Yes, absolutely.
It's easy, and it's free. It's important. And so many questions in my head. Maybe what is also the impact for Crédit Agricole to use and to go on this way? It's important team actually, or it's just few people for beginnings? When it starts?
Yeah, in fact, when we started, so it was in 1999. 20, sorry, what millennium I'm confusing, sorry. In 2019, so we were four. So 4 fellows interested by quantum computing. What could it be? Okay, let's meet, etc. Here and there. And then we discussed we presented some, let's say, potentiality, and we were not fully convinced, but fully convinced that it was interesting to investigate more. So we discussed with the management, and they said, okay, you can do more. So can we have can we have some means for that, a team, etc.? Said, no, you are for, it's fine. Okay, so let's do that. So, and then we started to discuss and see with who we could do this box. We met Pascal, we met Multiverse, etc. So with that, after we were still 4, plus all the person here and there interested, and this let's say this number of persons grow, not a lot. I wouldn't say that we have a team for that, but we have, let's say, a set of persons within Crédit Agricole who are aware. We have some use cases that are fruitful. There is, let's say, academic watch on this, which is constant. I wouldn't say that it involves a lot of persons internally, but definitely the impact can be so huge that we will probably grow.
Good. All right.
Okay. All right.
Thank you for playing along. I apologize for throwing that at you. Minister is in the
Thank you
building,
very
so
much.
we're not far. Give him a huge round of applause, please. That was wonderful. Thank you.